Hello YouTube viewers, hope you're all doing good. Welcome to this video. In this video I'm going to talk about dynamic NFS provisioning in Kubernetes. Okay, while I'm talking, I'm going to start my cluster. So as usual, I'll start all my demos from a clean cluster. So cd to play directory. I'm going to git clone my Kubernetes repository. The GitHub repository link will be put in the description if you want to download. cd to Kubernetes and then to Vagrant provisioning and do Vagrant up. So this is going to provision a 3-node Kubernetes cluster with 1 master node and 2 worker nodes. All of them are CentOS 7 VMs running on virtual boxes. Okay, let me bring up my nodes. Okay, in all my previous videos, whenever we need to use a persistent storage, we end up creating persistent volume, and then we create persistent volume claims, and then we use those persistent volume claims in our pod or deployment or whatever it is. If you happen to use one of the cloud providers, for example GKE or EKS from Amazon or Microsoft Azure, you can make use of the dynamic provisioning. So if you're a cluster administrator and you've got a large organization and users want to deploy their application which needs a persistent storage, then as a cluster administrator you would have to create the persistent volumes. Only then users will be able to claim those volumes using persistent volume claims. But that's time consuming, and for every persistent volume claim you need to create a persistent volume. So there's a concept called dynamic provisioning where users can request persistent volumes using volume claim template or persistent volume claims. Behind the scene there is a provisioner that deploys the persistent volume on your behalf. So as a cluster administrator you don't have to create persistent volumes anymore. So all the persistent volumes will get dynamically provisioned based on the persistent volume claim. And when you delete the persistent volume claim, the associated persistent volumes will also be deleted. So that's the kind of situation on the cloud side. But what if you use your own cluster? For example, as I'm showing in this demo, I've got a Kubernetes cluster set up on my local workstation. I haven't got access to the cloud for this cluster. So in my case, in all my previous videos, I had to create the persistent volume myself before working on the pod and persistent volume claims. I came across something called NFS client provisioning. If I open up my browser, NFS client provisioner Kubernetes, and the first link here is a GitHub link, and you can go through this. Basically I made use of this repository to create my custom provisioner. So you can also use Helm to install the NFS client provisioner, but I'll show you how you can use the normal YAML file. So the YAML files are all in this deploy directory. But I've copied it to my GitHub Kubernetes repository. So I'm going to show you what and how it works. Okay, looking at my nodes, how it actually works. The idea is you need to have an existing NFS server anywhere. You need access to that NFS server. So for example, in this demo, I'm going to create an NFS server and I'm going to export SRV NFS Kube data from my host machine. So that's going to be my NFS server, and on my same workstation I've got a Kubernetes cluster which is coming up with kmaster and kworker1, kworker2 2 nodes. What I'm doing is I'm deploying a special type of pod called NFS client provisioner. So what it does is when you deploy this pod, it's going to mount this volume SRV NFS Kube data within slash persistent volumes in this pod, and that's the provisioner. And we need to create a storage class and point that storage class to this um, pod. I'll show you how it works, but that's how it works. This pod can run on any of your worker nodes, so you need to make sure that this pod is always running. So that's the gateway. So using that, it will actually provision the storage for each of your persistent volume claims inside the persistent volumes directory, which is actually mounted NFS volume from here, SRV NFS Kube data. Okay, so as part of it, we are going to create a service account, a role binding, a cluster role binding. All these role and role bindings are for this service account, and we're going to create a storage class, and we will create a deployment for this NFS client provisioner. So that deployment will create a replica set, and there will be one instance of the pod running under that replica set. Okay, so that's the theory behind NFS provisioning, dynamic NFS provisioning. Let's see what's the status of our cluster. So it has done the K master, and it's doing K worker 1 at the moment. I think it's going to take another 4 or 5 minutes. Okay, I'm going to pause the video here and come back when the clusters are ready. Right, all the nodes are ready. The cluster is set up now. What I'm going to do now is I'm going to copy the Kubernetes config file to my host machine from kmaster, so I can run kubectl command from my host machine to interact with the cluster. Okay, let's look at the status of our cluster. Kubectl get nodes. Okay, 3 nodes, all of them are ready. Kubectl get component status. They're all healthy. Kubectl version -- short. I'm on version 113.2. Okay, right. So I'm going to set up the NFS server bit now. I'm on Arch Linux. If you happen to be on Arch Linux, you can follow the steps. Otherwise, I'll leave it with you to set up and configure your NFS server. So I'm going to make directory sudo make directory srv nfs kube data, and I'm going to change the ownership to nobody. If you're on CentOS, then it's going to be NFS nobody and srv nfs kube data. And I'm going to edit. I'm going to enable and start the NFS server. If you're on Arch Linux, the package you need for NFS functionality is sudo pacman -s nfs utils. I've got that installed already, so I'm going to enable and start the service. Sudo systemctl enable NFS server. Sudo systemctl start NFS server. I haven't got any firewall enabled, so if you've got firewall enabled, you need to open up a few ports for the NFS server. Next, I'm going to edit the etc exports file. So the directory I'm exporting is srv nfs kube data. I'm exporting it to the world with some options: read write, sync, no, subtree check, no root squash, no all squash, insecure. Okay, once you've done that, you need to export it. -RAV. If you do export fs -v, it will tell you what has been exported and to what with what options set. Okay. I'm going to log into one of the worker node quickly to check if we can mount this NFS volume. K worker 2, for example. Mount -t NFS, and the IP address of my NFS server is 10.95.65.213. srv nfs cube data /mnt. Cool. I can mount it. Mount grab cube data. Cool, that's there. Let me unmount it and exit out of it. Okay, cool. So our NFS server bit is ready now. So now we need to deploy this NFS client provisioner pod. Okay, so in my Kubernetes repository, if I go one directory above and then to cd YAMLs, cd to NFS provisioner, I've got three YAML files. The rback.yaml file is to create the service account and the role binding, cluster role binding, role and cluster role. Class is to create the storage class, and deployment is to create the actual deployment for this pod. Okay, let's take a look at each of these YAML files. vi rback.yaml. You can see I'm creating a service account called NFS client provisioner. I'm creating a cluster role called NFS client provisioner runner. And the rules are, I've restricted the rules so it can only do these actions on these resources. Okay, for example, on persistent volumes, it can see persistent volumes, it can get, list, watch, it can create or delete persistent volumes. Similarly, persistent volume claims, it doesn't have permission to create it or delete it, but to see it, update it. Storage class, it can create it, it can get, list and watch, and the cluster role binding. So basically that's the cluster role, and in cluster role binding, I'm binding that cluster role to that service account. So basically I'm binding the cluster role NFS client provisioner runner to the service account NFS client provisioner. So that's cluster role and cluster role binding. Similarly, I create a role and role binding. Let's create that. kubectl create -f. If I do kubectl get cluster role, cluster role binding, role binding. Okay, so we've got those default ones. If I grep for NFS, I haven't got any. So now let's create these service account and role bindings. Okay, so that has created the service account, cluster role binding, role and role binding. If I do that same command again, you can see it has created the cluster role binding, role and role binding. Cool. Next, we need to create the storage class. So storage class is the important object here. Class.yaml. So we are deploying a storage class resource, and the name of the storage class is managed NFS storage. So that's important. Whenever you do a persistent volume claim, you need to mention this storage class, otherwise it won't provision the persistent volume. And the provisioner, I gave it a name, example.com/nfs. Okay, so that's the class. Let's create that file. kubectl get storage class, nothing found. kubectl create -f class.yaml, storage class got created, and you can see the storage class managed NFS storage. Okay, that's cool. And finally, let's look at the deployment.yaml. So we are deploying a resource of type deployment, and the deployment name is NFS client provisioner with one replica, and we are going to use the service account we created earlier, NFS client provisioner. The container image is from Kube.io, external storage, the latest version of NFS client provisioner. Volume mount. So we are going to mount something under /persistent volume. So that's what I mentioned here under persistent volume. It's going to be the NFS volume from our NFS server. And environment name of the NFS server. So I need to update my NFS server's IP address here. The NFS path is srv NFS Kube data. So that's the volume mount section, which is referring to the NFS client dash root volume, and that volume is defined here. Again, here I need to enter my NFS server's IP address. So that's it to it. It's going to create a deployment of this pod, and it's going to mount the persistent volume from the NFS volume here. Okay, let's create it. Watch kubectl get all. There is nothing at the moment, and I'm going to deploy this. Kubectl create -f deployment.yaml. That's created, and that's the deployment, and it has created a replica set, and the replica set created the pod. It's creating the container at the moment, and the container is running. Okay, so let's take a look at that part. Basically, this one here, the pod, is the pod that I mentioned here. kubectl describe pod NFS client provisioner piping that to less. You can see the container image that I mentioned earlier, and the environment variable, what's our NFS server and what we are going to mount, and the mounts are /persistent volumes. So that's mounted from the NFS client root volume, which is down here, NFS client root, which is an NFS mount, and that's the server IP and the path we mounted. Okay, cool. So kubectl get pv, pvc. We haven't got any persistent volumes or persistent volume claims. Okay, so now let's test it. So now I'm gonna create, I haven't got any persistent volumes. Kubectl get pv, there are no persistent volumes. If I do ls srv nfs kube data, there is nothing in that NFS volume. I'm going to create a persistent volume claim. Okay, so if I go one directory above, I'm going to reuse one of my earlier YAML files, vi for pvc nfs.yaml. Okay, so that's an example of a persistent volume claim. The name of the persistent volume claim is pvc nfs pv1. For example, let's change that to pvc1. So that will be the name of our persistent volume claim. Storage class, that's the important bit here, and the storage class we defined was managed NFS storage. If I do kubectl get storage class, so that's the storage class we are going to use. Read write many, that's okay. Request, so I'm requesting 500 meg of storage. Okay, let's try and deploy this. Kubectl get pv, pvc. Okay, no resource. Let's create this. So as I told earlier, we haven't got persistent volume. We are creating a persistent volume claim, which is going to trigger the NFS provisioner, and it's going to create a persistent volume for us dynamically. So we don't have to worry about creating the persistent volume. Okay, persistent volume claim created. And you can see here, that's the persistent volume claim, PVC1 we've created. And it's already bound to a persistent volume. So we didn't create this persistent volume, PVC something blah blah. And read write many, storage classes managed NFS storage. Access mode is read write many, capacity is 500 meg. Cool. So the persistent volume got created automatically. And if I do srv nfs kube data, you can see there is a directory now that got created. Is there anything in that directory? There won't be anything in the directory, but the directory got created. So that's the persistent volume, dynamic provisioning of persistent volumes. Okay, let's try to create a pod and consume this persistent volume. Again, I'm going to reuse one of my earlier YAML file. Busybox persistent volume host path. This is the YAML file that I used for one of my video earlier. So it's basically a pod. The pod name is going to be Busybox name, volume name, persistent volume claim, and the claim name, I'm going to change that to PVC1 because that's the persistent volume claim that we created. And under the volume section, volume mount, I'm going to use the same volume, and I'm going to mount it under /mydata inside the container. And this container does nothing but sleeping for like 5 minutes, 5 or 10 minutes, 10 minutes. Okay, let's create this one. So it's basically a simple pod that's going to make use of our persistent volume claim that we created earlier. Okay. kubectl get pods. So that's the only pod that we have got, which is the NFS client provisioner pod. Okay, let's create this Busybox pod now. kubectl create -f. Okay, pod is created, and you can see here the container is getting created at the moment. Let's wait for it to... Okay, so now the container is running. If you take a look at the pod, describe pod Busybox. Okay, so /mydata is the volume, and it's getting mounted using the persistent volume claim. Okay, cool. I'm going to get a shell into this Busybox container, and I'm going to run some data. I'm going to create a file. kubectl exec -it for interactive Busybox, and the command that I need to run is shell. Okay, so now I'm inside the container. If I do ls/mydata, there's nothing. I'm going to touch a file, touch hello, touch/mydata hello, ls/mydata. So you've got that hello file. I'm exiting out of it, and if I do ls srv nfs kube data, there, so there it is, hello. So it's making use of our NFS volume. Okay, so let's try and create another pod, another persistent volume claim, and another pod to consume it. kubectl watch kubectl get pv, pvc. So we have one persistent volume and one persistent volume claim. Let's try and create another one. For PVC NFS, it's the same persistent volume claim YAML file, and I'm going to change that to 2, and the storage class name has to be managed NFS storage. Read write many, let's change that to read write once, and 500 meg to just 100 meg. Let's deploy this. kubectl create -f, the YAML file. Okay, so it's in the pending state. We have to wait for a little while. Persistent volume claim, and the claim name is pv2. Okay, so now it has created the persistent volume for us, and the persistent volume claim is already bound to the new persistent volume that it has created. And you can see the capacity is 100 meg, read write once, and the storage class is managed NFS storage. Cool. And now if I take a look at the directory srv nfs kube data, you can see there is a second directory here. Okay, cool. And let's delete it. Let's delete the pods. If you delete the pod, it's not going to delete the persistent volume claim because we manually created the persistent volume claim. And once you delete the persistent volume claim, it's automatically going to delete the persistent volume. because if I do kubectl get pv and pvc, the reclaim policy states delete. The reclaim policy is set to delete. So when you delete the persistent volume claim, the persistent volumes will get deleted. Let's check that out. First, let's delete the pod that's using these persistent volumes. Kubectl delete pod Busybox. Okay, the pod has been deleted. Kubectl get pods. So that's deleted. Kubectl gets pv, pvc. So you've got the persistent volume claim. I'm going to delete the persistent volume claim. Kubectl delete persistent volume claim minus all. So I'm going to delete all the persistent volume claims and not the persistent volume, but you're going to watch the persistent volumes will also get deleted now because the reclaim policy is set to delete. Okay, so that's deleted and the persistent volume is also gone. Kubectl get pv, we don't have any persistent volume, so that's dynamic NFS provisioning. And if I do srv NFS kube data, the directories, these two directories that we had earlier, are gone now. Cool. That is how you would normally use the dynamic storage provisioning. It's an external provisioner that you can use in your cluster, but if you're using cloud providers, you don't have to do these extra steps. You can straight away define a storage class and then start using the storage class for provisioning persistent volumes. Cool. If you've got any issues or any problems following this tutorial, or if you don't understand any part of it, just leave me a comment and I should be able to jump in and help you. And if you like this video, please share it with your friends, and don't forget to subscribe to my channel. I've got lots of Kubernetes videos waiting in the queue, and it will be posted once every week, and usually on Mondays, and you'll get notified if you subscribe to my channel. Cool, thanks for your time watching this video. I will see you all in my next video. Bye bye.